Hi, my name is Bella Keller, and I'm the lead programmer for Team 1425 DuBois area.
And I'm Nick Evans, a junior programmer. This is our Simulink code for the 2025 Best Robotics Competition Factoids. This year, we faced some new challenges as we implemented the new V5 control system. Looking back, we are grateful for these challenges as they forced us to learn more about Simulink and become better programmers. One example of this is how the V5 controller blocks do not have input ports to use with the USB controller during simulation. To avoid constantly switching out portions of our code when compiling or simulating, we combined all of our input signals into two different buses, one for code generation and one for simulation. We then used a variant source block to automatically switch between which signal bus is used in the code. Similarly, we also combined our actuator outputs into a single bus. We feel that this practice has greatly simplified our coding and makes it easier to modify the code. We worked closely with our drivers to develop a tank drive system that offers precise control. To do this, we used a custom MATLAB function that maps the control signals for low-end precision and only reduces top speed when desired. It also scales the signals so they work properly with the MC55 motor controllers, which aren't yet fully supported by Simulink. Our robot uses an intake to collect factoids, which are then raised to the top of the robot by an Archimedes screw linked to the same motor. Two triggers and a digital button control the parallel state flow logic. One trigger toggles the system on and off while the other controls direction. If the system ever jams, the motor will draw a higher stall current and the state flow momentarily reverses the system to unjam the factoid. To sort the factoids, you use a fully autonomous weight-based system with an IR sensor and a limit switch. As the factoids leave the Archimedes screw, enter the sorter and trip the IR sensor. Heavy or true factoids trip the limit switch and are sorted to the right and held in storage. Light or false factoids are sorted to the left and deposited into our fake news container. To score factoids in the neural network nodes, we have a servo-controlled chute that moves between three positions, against the robot to meet compliance, and two settings for high and low node scoring. The state flow automatically moves the ramp to the low scoring position as soon as the intake is turned on. To place factoids into nodes, another servo toggles the release between two positions, delaying long enough to ensure full servo movement. We start the match with a folded detachable tray on the end of our arm to carry all 5 neural network connectors at once. Once the tiles are placed, a servo rotates one of the two team custom parts 30 degrees to unlatch the tray. Without the tray, the TCP on the end of the arm is used to turn the neural network mode selector. With that task completed, the servo turns the final 10 degrees to release the folding arm extension, allowing us to collect LOC factoids. Our arm is primarily controlled by 2 trigger buttons. We do, however, use a potentiometer to set movement limits and to allow autonomous movement to specific positions. With a single button press, the arm will automatically move to the correct position for turning the neural network mode selector. Additionally, moving both joysticks outward to the max position will trigger the arm to move past its normal limit to its actual limit, triggering the release of our false factoids so that they're not on the robot at the end of the match.